Hi guys, today's the next lesson in factoring, and today we're going to cover some special cases. Now the first two problems I'm going to do, they look a lot like the ones that we have been doing, and then the last two I'm going to do look different, but the process is the same. Okay, so the process is the same. The first problem, x squared minus 12x plus 36, and we want to factor this. Okay, so the process that we've been using is in the x box, and that will continue to be the case. So remember x, remember this first term here, this is my a, this is my b, and this is my c. And up here, it's a times c, and here it's b. So there's no number in front of the x squared times the 36, that just gets me 36, negative 12. And so here, we need to find what two numbers multiply to get me 36, but add and get me negative 12. Okay, and like before, if you don't see it right away, I just go down the list, 1 times 36. I can't add or subtract those to get negative 12. 2 and 13, that gets me 11, that doesn't work. 3 and 12 gets me to 15. Or 9, that doesn't work. 4 and 9, that can't get me to negative 12. 5 doesn't go in. And 6 and 6 work, but both of them will have to be negative. Okay, both of them will have to be negative here. So those go here, and then we create our box. Remember, our a term goes in here. That was just x squared. Our c term goes in here, and the parts that we just figured out, they go into the other two boxes. And it doesn't matter into which box they go. Okay, now I just start to factor out. I can factor out an x. What times x gives me x squared? That's another x. Negative 6 times x gets me negative 6x. Negative 6 on the bottom here as well. And then negative 6 times negative 6 gets me positive 36. So my answer here is x minus 6, x minus 6. And this is a special case just because the two factors are the same. And we can write them like this. Do another problem here. X squared plus 12x plus 9. So we want to factor this as well. Okay, and we're still using Xbox. Again, this is my A, this is my B, and the 9 is my C. 4 times 9 get me 36. This is positive 12. Okay, so we just did this. If both of these are positive, then that would be good, right? It's because they would multiply to get me to 36. It would add and get me this 12 on the bottom. Okay, so these guys go into the box. Remember, what's our A term? Our A term is 4x squared. Our C term is 9. And then the two 6x's can go into either side here. So I'm going to factor up out of these guys here first. And I can factor out a 2x. So what times 2x is going to get me 4x squared? Another 2x. What times 2x gets me 6x? That's 3, and the same thing here. So we see that 2x plus 3 times 2x plus 3, or 2x plus 3 squared. Okay, so these are just like the two that we've been doing the past few weeks here. And um, but when you look at the answers, you can see why that there are special cases. Now, these may not be easy to recognize as special cases, but the next couple will be. All right. All right, so the next one that we're going to factor, it's going to say factor this. Okay, and we notice that this one only has two terms. All the other ones that we've been factoring have looked like ax squared plus bx plus c. So start to match these parts up. The x squared, this is this piece. We don't have one that has this bx. Our c term is just our straight number or our constant. So in this problem, we have a, okay, we have a, this is our a. We don't have a b, and we have a c. Okay? But the process is still going to be the same. We're actually still going to use the Xbox. Okay? And the parts of the Xbox are still the same. A times c goes up top, the b goes down on the bottom. So the number in front of the x squared, there's no number there, so we assume that's 1. So that's negative 25. And because we don't have a b term, we're just going to put a 0 there. Now, I need two numbers that multiply to get me negative 25, okay, but add up and get me 0. So that means whatever these two numbers I choose, they have to be the same number. One has to be positive, one has to be negative. That's the only way we're going to get this 0 on the bottom. And what times what gets us 25? It is positive and negative 5. Okay. Now, because the coefficient in front of the x squared here is a 1, we don't actually have to do the box. But I'm going to do the box anyway, just to show you that it does work. So anytime you're factoring and you don't know what to do, you can always use Xbox. Okay, so the a term still comes in here. The c term comes in here. Now, these 5s will go into our other two squares, 5x and minus 5x. Okay, so I want to factor up first. What can I factor out? I can factor out an x. So what times x gets us x squared? Another x. What times x is going to get me this negative 5x? That's going to be a negative 5. What times x is going to get me positive 5x? And that's going to be a positive 5. So I'm done factoring. X minus 5, x plus 5. Okay? So again, this is a special case. Notice that the signs are different here, the 5x and the plus 5x. These signs are different. Okay? So it's not a squared term. Okay? This type of problem, okay, this type of problem, we call them special cases. This is what we call the difference of squares. Okay, and what do we mean by squares? This 1 is a perfect square. The square root of 1 is 1. The 25 is also a perfect square. The square root of 25 is 5. And we see those answers represented here. Okay. One more problem. Okay. So again, we can look. This problem is the difference of squares. 9 is a perfect square. 49 is also a perfect square. Okay? So the more you do these, you'll see that there is a shortcut, okay? But I still want to continue to use Xbox just so you guys kind of have something to always fall back onto. Remember, this is our A, this is our C. Do we have a B? We don't. So our B is going to be equal to 0. Okay? So if I want to do this, this number is going to get pretty big. Okay? This number is going to get pretty big, and it's going to be a headache. Okay? So 49 times 9, okay, off to the side here, this is going to be 441, and this is going to be 0. Okay, so I need two numbers that multiply to get me 441. They have to be the same number, okay, and they have to be the same number, okay, and they have to be opposite signs. Okay, so we can go through 1, 2, we can keep going, but we know that these numbers are going to have to be pretty big. Okay, down the line, you're going to come to negative 21 and positive 21. Okay, one thing that you can always do is, because we know that this is difference of squares, I can take the square root of 441, which gets me 21. And I'll show you the shortcut in red kind of after this, so you don't have to do all of this. But here is our box. 9x squared goes here. Negative 49 goes here. 21x and negative 21x, they both go into here. Okay, so I'll factor this out in yellow. Okay, so what can I factor out of here? I can factor out a 3x. So what times 3x is going to get me 9x squared, another 3x. Okay, what times 3x is going to get me negative 21x, and that's going to be a negative 7. To get positive 21, that's going to be positive 7. And our answer is 3x minus 7 times 3x plus 7. Okay, so when we look at the original problem, and this is where you guys need to start to understand and see that this is a difference of square problems, is you recognize that this 9 is a square, perfect square, so is this 49. Okay, the 9, I just take the square root of this 9, it's going to give me this 3x. And actually, x squared, okay, is also a perfect square. X times x gets me x squared. And to get a negative 49, I know that one sign has to be positive, the other sign has to be negative, and then the square root of 49 is 7. And we get the same answer as we got before. Okay, so watch the types of problems I have given you examples for, and then afterwards you guys should be able to get through your IXL assignment here. All right, bye guys.